and it sort of leads to this online learning connection. But the main message here is 10 years or so ago, I started teaching the networking courses, the upper grad sort of concentration networking courses at UC Santa Cruz. And this was after having been a network engineer for a number of years and freshly minted PhD, and figured I had the perfect solution to how to deal with all this teaching and do it right when what I had to suffer through. I would be able to fix all that. Within maybe 3 or 4 weeks after starting teaching my first class, I realized I had no clue how to actually motivate students, how to actually present material in a way that people wanted to learn about it, right? So I sort of started a 10-year effort to try and figure that out and figure out how to make networking actually an interesting topic and to present it in a way that really was compelling and got students engaged. One of the first lessons, and this is the story of one aspect of that, one component of taking a lot of the content, turning it into this sort of problem-oriented lab kind of component to the course that didn't exist before, that really ended up having a huge impact on the ability to teach a lot of really kind of involved and abstract and not very connected with anything else kind of concepts. One of the first lessons I had to learn was that networking really does not lend itself to traditional lecturing kind of instruction. It's a bunch of, and this is Scott Schenker. If some of you have seen him talk, he's a very excellent speaker, compelling speaker, faculty at UC Berkeley. He teaches the network. He often teaches a networking course at UC Berkeley, and in beginning to research what was going wrong with this teaching of networking, I stumbled across his slides from the equivalent course at Berkeley, and he had a whole section, half a dozen slides on this topic, saying why are networking courses so terrible, and the issues he identified were that as a research topic, it's been very ad hoc. Protocols have been developed for various purposes. In the early years, there was not a whole lot of kind of formal methods to it, no proving, no nothing. It was a very try something, tweak it, make it work. You can think of some of the really popular protocols now or widespread protocols like BGP, where essentially I don't think the inventors would argue with me calling them hacks that sort of evolved and now glue the whole internet together. They're really just this random bag of technology that's been thrown together to make things work. It's not a compelling thing to sit and lecture on, right? It just sort of, it ends up feeling like it sort of was my experience of the first round of organic chemistry, where they say, learn all this, and then just, here's a model that failed, here's a model that failed, now just memorize. And networking is essentially just memorized from the very beginning. There were really no models. So the big insight on that is that for me there was sort of an explanation of why I was having a hard time getting this across. It's just this random set of technologies that you're needing to present to people in a way that is compelling, gets them wanting to actually learn about it, which is very hard to do. So looking at other disciplines, I had taken chemistry and physics when I was an undergrad, so I thought these labs that we used in chemistry and physics, and I'm not actually comparing chemistry and physics to networking or to even computing in general, because they actually are tied to some physical reality, right? So you're learning something that has some constraints that make sense in some way, that you can sort of build up from some underlying principles. And in networking, to some degree, that's not true. It's a total construction of human minds that's not tied to reality in the same way. But the idea of doing labs made a whole lot of sense. I thought, okay, I can bring this down to earth and make it interesting by turning it into some labs. So I worked with Cisco. I was actually in the middle of a large project and was talking to the right people at Cisco. Got a big donation of, ended up being like a $400,000 donation of a bunch of gear to set up a very nice network lab at UCSC to begin teaching these classes. And so this on the right over there is, there was 10 pods that were composed of 4 Linux machines. You can see the Linux machines down here. and a bunch of network gear which had 4 routers, a couple of switches, a firewall that you can't see up there. Everything, all the components of a networking system, patch panels that gave students the exact sense of what it was like to configure and run a network, and developed a whole series of labs around that so they could sit and use a real environment, do it just like network engineers to do configuring this network environment to learn all these different protocols. The students loved it. This is sort of a quiet beginning of the quarter. Last quarter, normally the racks are full of cables dangling and sort of chaos, and the labs are generally get more and more busy as the year goes on. So the students loved it, but there were problems in that it was a physical lab. You had the limitations of this physical hardware. You were dealing with all the infrastructure support issues with that and the costs, but more importantly was it really didn't have the ability to sit there and experiment, try things. This problem-oriented model of education, and I bring that up a few times. I got that sort of somewhere in the early part of this. I put in an application to NSF with one of my colleagues in the computer engineering department. And NSF, to their credit, it was to get funding to develop lab-based curriculum for networking. They said, if you're going to apply to this program, which was focused on education, please go out and read all these articles that give you some sense of what has been learned over the past decade about what works in teaching people. And it was a great, I took it seriously and went out and read them all. And the gist that I sort of distilled out of it is the way to get students, people engaged in learning some new material is to pose them a problem, have them solve it real time in class or as a part even of their homework. So make it problem oriented and make it social, so they're actually interacting. It's sort of group oriented kind of stuff. That's what motivates human beings, and especially on the problem solving side, that's what motivates engineers. And that's how you really get people engaged and get them really plugged in and wanting to learn something. So the problem with a physical lab is you weren't able to save state. You had to sit down and run through some lab that would actually have some reasonable confidence that you'd come to the same conclusions, that you'd actually not get off the tracks and out into the weeds and get totally lost. So it was fairly tightly controlled. And you ended up really having to do this in one sitting. You had to sit down and run through the whole thing, gather all your data. It was sort of modeled after chemistry or physics labs where it would go through, run these steps, gather this data, and when it was all over, go write up a lab report of what you did. The problem with this sort of very structured one-pass kind of thing is that it eliminates this, solve this problem. You end up sort of a scripted kind of thing, and you'll see this in a lot of networking education labs, is you do all these steps, gather this data, and run a report. You're not solving a problem. You're basically running through this recipe to gather the data and generate the report. It's not engaging you the way you really need to. And so I ended up realizing it was really, Cisco does this a lot in their certification training. It's a great sort of interactive documentation where you can learn sub-technology, learn the commands that are needed to do stuff. It looks like this. This is pages. This is probably a 7-page lab to teach people RIP, which is a routing protocol. Routing Information Protocol is what RIP stands for. And you see a description of the protocol. You see the commands you need to use to configure one of the routers. You see here how to configure Linux to do RIP, and then, because we always wanted them to do both the router and Linux. And then it shows you what data gather and what report to write. The floppies are data to gather. The little post-its are, this is what you need to write up in your report. And it goes on and on like this. This is many pages. So the challenge with this is that it's just, again, sort of monkey see, monkey do. And the students love the labs, love actually working with real equipment, love developing some skills and using stuff that they could see would be valuable after they graduated. But they would end up showing up, running through the lab. They were supposed to prepare ahead of time. They'd end up showing up, run through type in the commands, gather the data, and hope they had the right information when they wrote the lab report. From the pedagogical side, it really made it hard to get them engaged, to pose a problem. Here's set up this kind of environment, figure out how to do it, and explain to me that, show what you did. So it really didn't work. It was a $500,000 experiment that was a big improvement, but really still was a little bit painful. When I took over the class, it was 5 to 10 students. This was the advanced network class where I really integrated this stuff into it. And over the 3 or 4 years that I ran it using the physical lab, it maybe got up to over 10. It sort of got more popular, but not a lot. So the message, the lesson I learned there is that labs are not just in and of themselves going to all of a sudden make education better, that having students do hands-on implementation or use of the technology is not alone really going to be the compelling make the material really interesting. And in realizing this, I began looking around and found that there was technology out there that allowed me to duplicate that lab completely, actually with more functionality, in a virtual computing environment, which was kind of stunning from a networking point of view because you have all these cables and everything. And it turned out that all the software was out there, and the components of the software, all open source. The one I'm using, although there's since then Cisco's putting out one that's it's more focused and is certainly Cisco specific. But this one is using VirtualBox that a lot of people may have heard of as sort of an open source VMware kind of equivalent. And there's someone had written an emulator for the MIPS platform. That's this Dynamips. That turns out most of the Cisco gear is based on MIPS, and so it could actually run real Cisco iOS images, Cisco's operating system images. And what I did was I packaged it all up into one VM for each student. They get to log in and run, and I pose them problems, so I'm going to show you a demo in a minute. So they each get their own essentially virtual lab that they can do what they want with. It's actually a bit more expandable than the lab because you can have many more routers in it. The one challenge is it actually uses a real Cisco iOS image, so I had to do some funny stuff with the way I configured the Linux that was the host environment. But it basically all worked, and here's how it looks. And this is actually how the students use it. What's amazing is I end up having them coming into my office. They'll work. I can't remember the password and talk at the same time. They'll be working on one of these labs, working on these concepts, get stuck, shut down the console application they have here, think about it, come to my office hours, open up their laptop, say, okay, I'm stuck, what's going wrong here? Or I'll see them in the lounges sort of opening it up and bringing up the same thing and working on some problems. So they sort of work on it over a period of time, solving a problem. And this is what it looks like. So I'm not going to bring in any hosts because the little embedded hosts that I run here take a while to boot up, but I'll just show you a quickie example. I'm essentially putting 2 routers in place. I'm going to give them configure them with an interface. I think I can actually set this up to do it ahead of time, but I figured it's good for them to be thinking about these kind of things. And then I can connect them with a little network, Ethernet link, and it actually will support serial links as well. I can boot these 2 little devices. I can bring up a console, which the network engineers in the room will recognize Cisco iOS booting. I can configure it. This is just giving it an IP address and getting it hooked up to the network. They can do the same on the other side. Now you can see that they'll actually talk to each other. And I can even, within the environment, bring up capture traffic and bring up Wireshark to look at what's going on. Just like just exactly like they were doing in the lab. So I'll run this ping again. And you can see all your traffic shows up over here. So it's like they're sitting there able to spin up. This is full iOS. It's a fairly well-featured iOS, so they can do voice over IP. I've had students do do projects on that. It's the full environment here. And they each get their own, and they can develop their own topologies, and off they go. So what that allows me to do is move to this is the same RIP lab covering the same material, and this is it. This is the whole thing. It basically says, set up this topology, come up with an addressing scheme, and prove to me, the step up here is prove to me you got it working. Gather enough information however you want to using configuration commands on the routers. In this one, I actually used some PCs in here to force them to learn how to do networking on Linux. Prove to me that you got it working. And then do this little tricky thing of figure out what path the traffic follows to get from here to here. Delete the link that it's using while you're running a command that sends a periodic ping message. And tell me how long it takes, watching the protocols, tell me how long it takes for RIP to converge on the new path, to realize the old one's broken and the new one's up, and explain to me what's going on. Why did it take that long? And it's all now in 2 pages, and they get to work on it. They get to figure it out. It can expand to, George, when he was looking this over, said, yeah, this is cute, but it's way too simple. So show him that there's something more interesting. This is a BGP. This is near the end of the quarter. I get them. BGP is the protocol that's used to Border Gateway Protocol. It stands for to tie the whole internet together, right? So it's fairly involved, subtle kind of protocol, and they are actually configuring a 4-area, 4-organization internet here, and setting up policies, using it to implement the typical kind of policies you can in BGP. So they end up basically configuring it, figuring out some issues, and then implementing typical policies, which is, one typical policy is if I have a provider that I get routes from and a peer that I get routes from, I prefer the routes I get from the peer because I'm not paying anything for that traffic. Another one, that's what I think this one is here. This one up here is saying I don't let my provider, anybody from outside the internet, use me as transit to get to my peer destinations. So this says set that up, and they do. And so this again, this is BGP, and it's fairly complicated. It's a 4-page lab. So and they get to just sit there and work on it, and all this issue of monkey see, monkey do is out the window. The challenge here is how do they learn all the configuration. It's in general, what you want to be teaching in a networking class is the concepts, what's going on in the network, how do you, how are these protocols working? Not the details of how Cisco iOS or Junos or any of the typical iOS's network operating systems, what are the command structures? You want them focusing on the concepts and sort of as a side effect, they learn the details of one or the other. And so the one other component to this that I had to get going that actually the students came up with. They said, I did this sort of virtual thing, or from the physical lab, they said we need some more user-friendly kind of way of learning these commands. So we came up with a netref, network reference site, that lets you using tags and browsing. So if you wanted to learn about RIP, you could go into these tags and find the RIP tag. And it shows you we have 2 articles showing how to configure RIP under iOS. Gives you kind of everything you need. And the nice thing about this is I sort of make sure that everything's in here that they need for the labs. So I tell them up front, I'm about to teach this starting next week, so I got this all preloaded, is go to netref, right? You can go out there and try and learn RIP, iOS RIP commands from first principles, and you're going to spend a huge amount of time, or you can go here, and I guarantee you on those few pages, everything you need is there. So and then you can also, go and look at the Linux version of it, that kind of stuff. So that was the other component to this whole effort that was needed to really make it work. So now they're given basically an increasingly complex set of problems to solve, an environment where they can build everything they need and play with it and throw it out and start over again and save state, or just what they now do is just basically leave it running. And figure out, how to do the configuration using this resource we provide to them. And it's made a huge difference. The class is slowly growing. We're up over 30, rounding the corner to sort of the 40 and 50 numbers. And this is, over the past 5 years, the kind of comments I've gotten is and I attribute it 80-90% to this one move of giving. So now the class essentially looks like a string of problems that are covering technology, different protocols basically, that they need to learn that gets increasingly challenging, complex. And they have an environment, a tool that they can use to tweak it and play with it and learn things on their own time. They get basically a week per one, so I end up covering 8 basically different concepts. And they went from sort of not many students, and they always were very friendly on the reviews, but it's because I was a nice guy, and you could tell they were like, okay, this is interesting. And when they got to do the hands-on, they got a little more interested. But the whole thing changed when we did this virtual lab environment where they could have their own environment to play around with and actually learn all these things. So that is the punchline. That's everything. Any questions? The online part of this, I should make one last thing. I haven't gone to the online part. It's all set up, I realize, to where all I need to do now is get lectures online, and most of this could actually be done. So there's been discussions coming about with this virtualized. I was talking to some of the cloud folks out here. How do you scale this to where you could really do this whole class online? And it's really the lecture side of it, which at this point is 1 day a week and fairly minimal amount of effort. You going to put something up?
Yeah, I just wanted to mention some things.
Okay. So that the online piece of it is really happening slowly. And there was one more point. Generalizing this to other disciplines. I would say the main thing, and I don't know how well this will map, but giving this idea of virtualizing some given technology that you need to teach some other area in would be giving a virtual environment where people can play and you can just pose them a clean problem that's summarized in a few pages and let them run with it on their own is a hugely powerful thing. That would be my last little question. Eli.
Yeah, so I really wish I'd had this when I was starting out. I mean, I'm serious. It looks really great. One of the sort of major strategic problems that I see for our entire community is pipeline for people.
Right.
And this goes a long way potentially toward, courses like this are exactly the sort of thing that we need. So where do your students go? I mean, so you teach them a whole bunch of good stuff. What do they then go? What do they go do? Do you hear about? I mean, do they go, work for Google or Facebook or whatever, or do they go work for AT&T? What do they go do after learning this stuff?
Work for university.
Yeah.
I can actually give you an example. If I may say something. So I have an interesting perspective on this whole thing. Back when I first started doing network engineering, and these are true stories, I've ended up tripping the circuit and driving out half nuts because I bought so much gear on eBay to be able to actually virtualize these things that it was just insane. And back in 2005, when Dynamips was a command line product, it was horrid to work with. It would eat up your CPU and so on and so on. And I actually took courses like Brad's, except in a community college that had all the gear was spent. Most of the class was spent just building the thing and then troubleshooting. And then by the time you were done doing all this, you were just exhausted. And then you're going home. And you come back and somebody else would take your stuff and tear it apart and go somewhere else. But I'm a prime example of a little bit of self-study, a little bit of taking classes like Brad's, and all my latest certs I did was, for example, using GNS3 and the like. And well, here I am working for a university and building out a large network and having a blast.
And that's not far from what I hear. I hear students going to the ones I've heard from have gone over to industry. And the emails I get back or the contacts I get back are people saying, along the lines of this guy right here, these are all anonymous, so I don't know what it was, but saying, I was surprised at how much I enjoyed networking. As I get probably over the 5-6 years that I've been doing it with this virtual environment, I've gotten a dozen emails back of people going to networking jobs. They're saying, I turned this into a career, working in the military, some do with defense contractors, some come from over the hill in the valley. So they get out into industry and start doing this kind of stuff. One of the big steps I wanted to do, I've always thought about wanting to do next is what I was calling an open source network lab. Would be the challenge with this is keeping up with new technologies that come out, right? I mean, the physicists and the chemists have it easy at this undergraduate level, and that things aren't changing a whole lot, right? I don't know. I may be wrong, but I think generally the laws of nature don't change nearly as fast as the laws of networking. And having the ability, what I wanted to do was what I would like to do, and I just haven't had the time to get it going, is where everybody, all the community can contribute new labs, making it open so that people, as they develop, as they say, oh, it'd be great to have a lab to cover this protocol, could just upload it and make it available to everybody. So open source it, have that idea that with enough eyeballs, every problem is easy. With enough eyeballs, every new technology is real easy to get a lab up for, to make it generally useful for everybody. Every once in a while, I'll get a query from somebody somewhere, often overseas, saying, can I use your labs? And I say, yes, please. As a matter of fact, if you come up with any new ones, contribute them. I think the next step is to open this, because I'm sure the labs I do could be improved on. I'm absolutely sure. This is first pass. A lot of this stuff, is with a lot of student involvement, and so there's a huge amount of improvement to be had there. Yes.
Well, I'm one of those ones who carried around gear for a long time, precious gear that I got from, the only real gift I got from the .coms going bankrupt was here's some routers, you can take them with you.
Right. I bought yours on eBay.
But it took a lot of work to actually get a decent rack of equipment, and it took time to set it up. I can't imagine somebody coming along and tearing it down, because sometimes you got to be in the zone for a period of time, and that period of time for individuals varies. So my question is, how do you get these students past that point where they actually understand what they're doing? In other words, you got to come in knowing a little bit about the OSI model. You're working at layer 2 and layer 3, and here's why things are flowing the way they are. Do they come in with some basic background so they kind of know what they're doing when they set up routing?
So they come in having taken a intro to networking course, so they've had a bit of that sort of architectural thing. They still are, it's a real challenge getting them engaged, to step up in action. They're used to sitting and getting a lecture. And, sorry. Okay, good point. I'll do this. I'll just sit next to this thing.
It's all good.
So they come in used to doing the lecture. So the way I really get them up to speed to where they're doing this fast is the labs start the first week. They have a lab due. I'll have my first lecture next Tuesday. The first lab is due Sunday, and it's a real super simple lab. It's something that's not much beyond what anybody would have done in setting up your stuff at home. So they all should have seen something like this. And the pressure's on to just do it. And it's a very gentle pressure. I mean, I'm not, but I just, before they have a chance to sort of freeze around the idea of having to sit down and configure stuff and make this whole thing work, they've done it, is really what it amounts to. I just sort of get them going really fast. And I also am building on the fact is some of the issues you're saying, like the OSI model and that they've taken an intro to networking class. So they have that behind them. Any other questions? All right. Well, then that's it. Thank you all very much. Thanks, George.